Hey everyone, Merry Christmas. It's Christmas time here in New Jersey and time to build some Christmas gifts. So I decided to put together a little montage of how I built a new kind of woodworking American flag. Wanted to build a gift for my brother and my father. And we also got a new machine at work that I needed to get some time on so I could learn it. And thought this was a good project. It's definitely was very challenging, challenged my woodworking skills and some of my machining skills. But I think you guys will enjoy how I made this new kind of flag. So I've always kind of been inspired by these kind of wavy wooden flags. Um, they're beautiful. Like this one, I really like. But this one is made of one piece of wood, and it's stained. The wood is stained or glazed in between each layer there, and it's a solid piece. They run a bit across each stripe there to kind of create a dividing line, and then put some paint or stain in between each stripe. And it's really nice. And but what I wanted is a flag that would show off the natural colors of two different kinds of wood. So I chose hard maple and cherry. And then I hadn't really found any great blue stains, so I decided to use epoxy, deep pour epoxy, to create the field of stars. And one thing that's always kind of bugged me about all these different kinds of flags out there, there's all different kinds, each have their own charm. And I really like this guy's video. Actually, in some ways, it's very similar to what I'm doing here. But one thing that's always kind of bothered me about these is geometrically, if a flag was waving, it would no longer be a rectangle. So, that's just kind of always bothered me a little bit. So I wanted to kind of solve that problem. And that introduces a whole new set of problems in how this thing is made and cut and milled. And so follow along with me on how I built it. And Merry Christmas, Brian and Dad. It was a pleasure giving you guys these flags a couple days ago, and I hope you enjoy them. Hope you guys enjoy the video and how I made it, and put some questions in the comments if you got any questions. I certainly made my fair share of mistakes along the way, so it was quite a learning experience. Hope you guys enjoy. So this is the final result, and I'm just going to kind of go through how we got here. But I'm really happy with this. I think it's very unique, and it solves the kind of geometric problems I was, kind of annoyed by. And man, this was a lot of work. So follow me as I go step by step how we started from concept to completion on this new kind of American flag. So we're going to use a CNC milling machine to cut the epoxy, to cut the stars, and to cut the different profiles in for each stripe. And so what we need to do that is a 2D file. So we need a DXF, an SVG, some kind of file like that. So where I initially started was thinking about modeling a flag myself and then using some 3D mesh modeling to kind of push and morph the flag into what would be an accurate representation of it flying. And that turned out to be pretty difficult, and I didn't think it was actually going to get me a result that was a lot better than what I could get by tracing an image that had kind of the profiles that I needed. So I kind of looked around for an image that I thought was good, and I found this one. So I had to kind of take this image and then turn it into a vector that I could edit. And even purchasing the vector would not have been kind of good enough. A lot of them come with tons of errors. So I decided to just kind of trace this image myself. So I started in Adobe Illustrator using Image Trace. And then I had to spend a couple hours kind of cleaning the image up. These stars did not draw properly from Image Trace, so I had to make a star for each one of them. And the real important thing is that every line crossing, actually does land on the exact same point, so that when you export this to like an SVG or something, you get something in your CAD software, CAM software that just kind of works. So this took quite a while of cleanup, but once it was done, I kind of had what I needed here, and then I could export this as an SVG and bring it into CAM software. So once we exported that file from our, graphics software, we brought it into Fusion 360 here, and I made several things from it. So I made a solid body to represent the whole flag, and then I made separate solid bodies for the individual components that make up each part of the stripes. And you can see that this is the stock that is going to, the stripes are going to be cut out of. And here's the stock the red stripes are going to be cut out of. So that's in cherry, and this is in hard maple. And one big mistake I made here is I really needed a larger piece of wood. This was just not enough space in between each stripe there to give us enough clearance to make really good hold down patterns and things like that. And then making the body here, we started with a, sort of a flat body and generated these guide curves. So I don't know if you can see this sketch on this edge here has a bunch of waves in it, these waves here, and they are cut through the body and follow these guide curves over to a smaller profile on this side. And this allows me to control the depth of these cuts so that I can see that when I eventually put the epoxy in here, there'll be enough depth for each star. So I had to kind of tightly control that. I really only thought I could mill down about 0.5 inch with the size tools I had, and didn't really want to risk going really small with tools. This is what we did in Fusion, and I'll start showing you how this all came together. So what we're starting here is by using a thickness planer to just kind of take the rough edges off both surfaces of the wood. And then we kind of let the wood sit for a couple days before we mill it, just to let some moisture out, moisture in, just to let the wood kind of stabilize. And that's pretty critical, so that it remains flat. I had to go back on the thickness planer again to kind of flatten it out just a little bit more. And now we use the CNC to drill some kind of strategic holes. So these holes are areas where I know the tool's not going to travel, where I can put screws to hold this piece of wood down to the table. So that piece of plywood underneath is vacuumed to the surface of the machine through a pretty strong vacuum, and then this wood is not really flat enough, nor does it really have enough surface area, in my opinion. So basically, it gets screwed to the piece of wood that's vacuumed to the table, and now we mill those pieces out. Now, ideally, I would have been able to mill straight down and through the piece of wood into the piece of plywood below it. But we were having some issues with splintering, and as you can see, I'm having a little bit of issue with dust collection there. I think this is due to the kind of tool that I had in the machine at this time, but we were getting through it, and where we ended up was just leaving the hole about 0.2, maybe 0.1 of an inch on the bottom there. So you can see that these pieces aren't cut all the way through, and then I use a bandsaw to kind of cut those individual pieces out. And once that's done, we'll go over to a router table and use a copy bit to bring these pieces to size. Ideally, I could have skipped this step, but we were having some struggles with the machine and the wood splintering and curling up when we went to put tabs in it. So this was the compromise, and now just using a copy bit to kind of remove that excess material on the bottom. This worked really well, but was quite a bit of extra labor that didn't really think was going to be needed to make these pieces. I think we could do better in the future. So you just kind of do this for every piece. I did have a couple pullouts in the hard maple. It just likes to split. So I was hoping to be able to have the edges of this piece exposed in the final product, but due to a couple little pullouts in the hard maple, had to put some edge banding around it. But this worked pretty well. It didn't take too long to do. And now we get to kind of gluing the pieces up. So pretty standard glue up, just kind of soak both edges here and work, from the bottom of the flag to the top. This did become more problematic than I thought, with the wood wanting to shift a little bit because of these kind of weird profiles. So it took a lot of time to sort of tune the clamping to get the piece to stay stable. The pieces wanted to kind of slide to the left or slide to the right, and so I spent quite a while tuning the clamping pressure on each clamp to kind of make sure they didn't want to slide. But overall, I'm pretty happy with how that came out. Could have probably used a couple more clamps if I were to do it again. And now just kind of sanding this edge inside where the Field of Stars is going to go, because going to put some epoxy there as a seal coat before the deep pour. And now I'm just using pieces of wood that are vacuumed to the table as a kind of a rudimentary fixture to hold this thing in place when we face mill it. I'd love to put clamps on top of it, but then you can't face the whole thing in one pass. And to take light passes, this seems to work pretty well. So you just kind of take a light pass and block the piece of wood in with other wood on the vacuum table to hold it, and do both sides of this so that we have kind of a pretty flat surface on both sides. And then we'll move on to prepping some of the seal coat epoxy. So this is leftover resin from one of our colleagues' projects here. So thanks, Adam. This was for a surfboard he was making. And just wanted to seal the inside surface of where the deep pour is going to be to prevent any bubbles forming during the pour. And here what I'm doing is drilling holes on the back side of the pour area so that the epoxy can kind of flow into those areas to create an anchor point, so that it's not only holding on the surface. And now just kind of seal coating this with epoxy, making sure I get into those holes with a brush, and sealing it up and let it cure for a day or so after this. And now need to make a fixture or a mold, really, to hold the epoxy in that area. So got some melamine board and just kind of tracing out and cutting this to size to form a little mold. Marking out drill holes and guides for holding these walls on, and then heading over to the drill press to drill all those holes, and then countersink all those holes to hold the mold together. One thing that I wasn't expecting is the deep pour epoxy that I got was a lot more viscous, or a lot less viscous, a lot more like water than I thought this particular epoxy was going to be. So had to really make sure this mold sealed very well, and I might really rethink how I did this if I were going to do it again. We did have some leaking problems. They were solved by putting weights on top of the flag, but basically this cavity is going to hold the epoxy in there, and then we're going to seal it against the underside of the flag there with a silicone caulk. But we did have some leaking problems, and I'm not sure this is the best way to do it, although I'm not quite sure of what another way to do this would be. But now coating all the pieces with Tyvek tape because it releases really nicely on these epoxy molds. And then just assembling this mold together so that it will hold the epoxy in that stars field there. Now just kind of assembling the mold together. So now what I'm doing is I had drawn the outline of the cavity on there and just kind of following it with a bead of silicone, and we're going to place the wooden part on top of the mold there and give it about a day for the silicone to cure. One of these worked really well and the other one produced some leaking, and like I said, we were able to solve it with a lot more weight and adding some additional silicone, but leaking under that edge was a bit of a problem. So just kind of waiting for this to cure and then roughing up that edge to what the epoxy manufacturer recommends, which is sanding with 150, and coating that surface in a little bit of blue tape to protect it, although we're going to mill it away anyway. So probably a step that isn't 100% needed. And one of the things you'll see later is that we poured this epoxy level, and I think I really needed to over pour. I think I really need to build this above the area because there was some shrinkage in the epoxy. So I think building this mold taller would have been advantageous. And now coating that inside edge with tape so I can spray it down with mold release and not spray the edge that it needs to adhere to. And just kind of checking my rough dimensions and calculating how much epoxy I need here, and doing a batch of deep pour for that area, and mixing in some mica powder, some blue mica powder, to give it the blue shiny look that we want. And then a degas, and it turns out I think that for degassing that much epoxy, I probably even need a larger degas chamber, because I couldn't really keep degassing. I had to release the vacuum quite a bit, so this took a lot longer than anticipated. Whereas with a smaller batch, you can kind of deal with that bubble uprise and just kind of let it keep on bubbling. So I would definitely go for taller vessels or a larger vacuum chamber for this much epoxy. I think that's the problem in this case. But it worked very well, just took a long time. And pouring it into that cavity there. And I divided it amongst two pours here, so I'll do another pour with the next batch right away. And here's what I'm saying. You'll see I'm working really hard to keep the epoxy like right at the level where I kind of want it, to try to not waste epoxy. But I think I would have been better off building a little dam around that area and pouring more epoxy to avoid that kind of edge shrinkage. So you'll see in the next shot, it comes back after it's cured, and it's kind of curled around some of the edges. And I haven't done enough deep pour to know if that's typical of these resins, but it seems that keeping the resin over the edge solves that problem. So you'll see we're going to do a pour again on this to overcome that problem, and I think that would have been a better place to start. So you can see, how much depth I kind of lost there. that top surface is almost level, but the edges have kind of curled down. Again, following their recommendations here to rough up the surface and really getting in those grooves and roughing it up and then wiping it down, getting all the dust out of there, and that black silicone there forming kind of a dam where I can pour over the edge, and that worked beautifully. So when this cured the next time, it came together very well, and you can't really notice it in the final product. So now grabbing a mallet here and just kind of disassembling the mold and banging it off here, taking all the screws out. The mold released very well. I definitely think that combination of the spray mold release plus the Tyvek tape created a mold that was really easy to release. Just a couple taps and the walls came off really nice and easy. Even the bottom with all that surface area came right off. And now basically, now that we have a defined shape, we need a way to locate that shape on the machine. So we're making a fixture here by just milling out what we don't want. And you can see we've been struggling with chip collection on this machine a little bit. I think we got the recipe figured out, but we basically mill this to slightly smaller than we want it to be. And you can see the flag doesn't fit in there. And then we take repeat passes in small increments to bring it up to the size that we want it. So it takes me 5 or 6 tries to get it right here. And you can see we have a pocket milled there for the epoxy overshoot there. And then what we use to hold this down is clamps. So you can see these 2 wooden clamps. Thanks, Danny, for helping me make those and think about the way to do it. And this epoxy chips, man, for us, it just clogged the hell out of the dust collection system. So got some changes to make there as well. But it worked really nicely. These clamps held it down very well. And then later, when we need to access the whole top, like now, we use little wedges. So there's about a millimeter gap around one side of the profile of the fixture of the flag that is in there, and we can use little wooden clamps that we can tap in to that gap to hold it down securely. And then if the tool comes around, it just mills that part of the clamp away. That worked really, really nicely for this. And now we use 2 really tiny tools. I think one is a 1/16 inch end mill. And so that's what's going on here. We started with a 1/8 to do most of the roughing, and then use a tiny little tool to come in and mill the pockets for all these stars. And using some hot glue to create a dam. Silicone would work just as well, but the hot glue sets up nice and fast, and I'm not pouring a ton of epoxy, so I think the hot glue works just fine in this case. And mix up a batch of epoxy, so I'm just double checking my dimensions, and I actually used the Fusion 360 to generate the volume of one of those pockets for the star. Multiply that by 2, since I'm by 100, since I'm making 2 flags, and then added a little extra volume, so I had enough to overflow all the stars. And I used a combination of white alcohol dye and a glittery mica powder to make the stars. I might have even gone more aggressive than this if I did this process again, although I think it came out really good, but I needed an immense amount of mica to really make this an opaque layer of epoxy in those stars, because they're not actually that deep. They're only about a ½ inch deep. So, but it worked out really nicely. And then I grab a syringe and just fill all of these up and to make sure there's no pockets where the epoxy is not flowing to. And then I kind of vibrated this just to make sure, but didn't seem to be any problems with that. And put it back on the machine and then start profile milling. So basically just taking a very small step over and milling the profile of the flag here. So this is like really, I guess this is technically three-axis milling. And this was a long pass. This was like a 2-hour pass. I could be probably a lot more aggressive, but given how much effort went in before this, I really just didn't want to push a tool or push the epoxy beyond where I could. So we just dealt with the long cut time, and off to the spindle sander to kind of clean up the edges so that when I put some edge banding around that, it adheres nicely. Sand up the back, and then go to town up to about 320 grit on the whole flag, and then up to 1,000 grit using these tiny little pads and a die grinder to polish up the epoxy there. I'm going to use Rubio Monocoat on the whole project. And so what you can see me doing here is just checking for areas I can see swirls and just polishing those areas up until the whole thing gets to a really nice polish. And I got a rebreather, a Papper respirator on, because this creates tiny little dust that you don't want to breathe. I just keep checking and checking until I get this whole thing up to the polish level that I want. And it took a while, and these discs worked pretty well, but I'd probably do a different solution next time. And then the edge banding, I tried doing it with an iron, and it just was a nightmare. So what I'm using is a metal dowel pin and a hot air gun. So heat up the tape and the part, and then push it in with a metal dowel pin to kind of move along. And then a nice long blade to kind of trim it down to size. Just kind of follow the edge and trim it down to size. And then apply some Rubio Monocoat and let it dry for a couple days. And that's it. So you can see the result here. Really happy with how that turned out. Learned a lot along the way. And Brian and Dad, Merry Christmas. And everyone, wish you all a Merry Christmas and a very happy New Year in 2025. Take care.